So let's get into really, okay, what is the rhizosphere? We've kind of been implying about it, kind of implying that it is this ecosystem, whatnot, everything else, right? What it is specifically by definition is a subsurface living matrix. That's right, folks. Soil particles, organic matter, plant roots, rhizomes, and perhaps most important, the diverse communities of microbes that decompose humic matter, process the resulting nutrients, and perpetuate the chemical, biological, symbiotic balance necessary for natural systems as a whole to prosper.
So
that's where all the magic is at. Don't kill
it.
We're Jug Dealers. We're the podcast you need in your feed. Teaching the game like you never seen. Jared, Gabe, Rambo, true OGs. Masters of the globe, set your mind free. From Denver, Colorado, where the data's green. We set the data points for the SOPs. Jug Dealers Podcast, yes indeed.
Hey, everybody. Welcome back to the Jug Dealers Podcast, where we discuss all things cannabis and lifestyle related. Brought to you by the good people at 5E. And now we have JugDealers.net for all your needs. We're definitely getting some action through there.
Yes, thank you for that very much, guys. We do have the merch up there, too. We've had some merch sales. We've got bottles going out. We're hucking jugs off of JugDealers.net. Check it out. And as I was just discussing with Grambo, we will continue to be evolving the website, adding more and more stuff, adding videos, adding, ability to reach out, technical questions, things like that.
And stuff. I mean, dude, if you guys have ideas for us, we'd love to hear it and implement.
Absolutely. And I would say even open call out for any, we were talking about doing, for example, an autos versus photos show, things like that. If you guys have any show ideas, open call out, please mention it to us, shoot us a message, whatever. We definitely we like hearing from you because we like giving you the content that you're looking for. Last open call out as well for people that, I don't know, it's summer, got thrips by chance. We've got some great products in the pesticide world. We've got the Russet, we've got the Multi, we've got the Eco that we put on top of that. You guys want any samples of that, let us know as well. Let us know if you guys want New Millennium Pet Pack samples. I've been getting a lot of those requests lately. Slicium, anything that looks good for you. Anybody working in a commercial grow and or home grow, we're open to all of it. Hit us up, JugDealers.net. Let's get the show started.
So it is the beginning of summer, and we felt it important to talk about one of the more important things this time of year, which is developing the root zone, because ultimately, if you have a good root zone, everything else is going to be a lot easier.
What have we always said? More roots,
more fruits,
more fruits. And I think that applies not only obviously to cannabis, but also to vegetables and things like that. And actually, you're going to see in an upcoming episode very shortly. We're going to do one on veggie gardening,
vegetables,
and so we're going to tie this all together. So our outline today, we're actually going to specifically be discussing the rhizosphere. We're going to define what that is. We're going to talk about its anatomy a little bit. We're going to talk about the root zone. We're going to talk about rhizosphere versus rhizosheath.
And honestly, one of the things that we both kind of discussed before this was the fact that I always, I had kind of used the term, rhizosphere loosely.
Yes.
In encompassing the root zone, in which they're not the same. They're not the same.
I was saying it even as somebody that's trained in horticulture, I was saying is basically everything that was below my feet, everything that was below ground. But that's really, that's the root zone. That's where roots can grow, right? And so I thought it was actually great. So that's where we're going to kind of start out is root zone to rhizosphere to rhizosheath, and kind of moving from big to smaller, and then really talk about why does that even matter, and the importance of bacteria and rhizobacteria and the biostimulants and this whole ecology that is there. And I will say right off the rip, again, another thing we were talking about right before we started, one of the reasons that we do talk about or are not that into some of these cleaning agents or clean growing or this kind of thing. Hypochlorous acid, right? One of the reasons we don't like that is that literally would take out this entire
wipes
episode.
It all out.
There's no episode, right? Because the reality is the word rhizosphere actually implies this living ecosystem that's going on, that's there, that's very, very close to the root, of which we're going to talk very specifically about. This is a beefy episode. I actually think this may end up being a 2-part episode. So buckle up, folks. We're going to start with the root zone. Again, the root zone, not to be confused
with the rhizosphere.
The root zone typically consists of sand, loam, topsoil, and other organic materials. People have probably heard of like a sandy loam soil, things like that. They've probably seen the soil triangle, which is sand, silt, and clay in the different percentages that it is, right? Pure clay being the smallest particle.
And if you go back to our previous episodes where we kind of break down media and stuff, we're encompassing let's say what you would use for vegetables, let's say some type of soil. And then beyond that, what we're giving you right now is actually, you know, kind of a textbook definition. We understand that when it says it consists of sand, loam, topsoil, and other organic materials that are blended together, if you're using rock wool, if you're using cocoa,
it's still a root zone.
Yeah, it's still a root zone. We don't.
Gabe was like, "Hey, man," he's
people
like,
are going to call us out on this.
And I was like, "All right, well, you are right. That's a root zone." Now, when I talk about things like the rhizosphere and the rhizosheath, now I'm not so sure that in those situations, that they are anything. What is right?
I mean, therein lies the question: is does something that is a sterile system, does it have a rhizosphere? I mean,
I would say it has a I get you know what?
Like this episode, like us discussing it now makes me pose that question. Because
here's the thing, and it, at the very least has to have root hairs, right? Because root hairs are what's going to be, that's where all the uptake's at. Even from from an anatomy standpoint, that's where all the way down at the end, like that's what's there and that's what's uptaking. So all the thick roots, all the things that we see, that's not really what's
that's why these high
that's just a water highway.
That's why these high EC setups really make me crazy, because it's like, man, any time where it dries out and you burn those root hairs,
well, you're screwed. So, I mean, I would say that it does imply some sort of living, and I would also say life happens. So I don't believe even people that are trying to clean grow are actually completely clean. It's just, this is not possible.
What do we say all the time? We say, sure, 17 essential elements to grow a plant. But to say that all these other things are not beneficial,
that's ludicrous.
And not for nothing. One of the things I really realized about this is, as we dive into this episode and we talk about some of these bacteria and these fungus that really work in conjunction with the roots to help them. To help break down some of these elements and sugars so that they're usable to the plant. Well, if you remove those things, that kind of starts to explain why you need to run your elements so high, because not only are some of these elements not really that available because they're not let's say the most bioavailable forms, but then you've removed some of the worker bees that do all this stuff to break it down. So all of a sudden now it starts to make sense. Yeah, I need to run my stuff at 4.0 and have a 4.0 and 5.0 runoff, because look, we removed part of the system.
Well, right. We took some of the biology out, which removed some system, like you said, removed some of the worker bees, removed some of the army that we had that we could have used at our disposal. One other thing very much worth mentioning is I did want to talk about the types of root systems. There's two of them. Dicots have taproot systems, while monocots have fibrous root systems, which is also known as an adventitious root system. That's also what you're going to see in clones versus seeds. You're going to see in clones, you're going to see that fibrous root system.
Yeah, so no taproot.
No taproot, right? So, and we did want to make sure and mention that. A taproot has a main root that grows down vertically, from which many smaller lateral roots arise. If it is a single leaf seed, and that is the first cotyledon that comes out, that's a monocot, hence mono. And is it a pair of leaves, then it's categorized as dicots. That's right at the beginning, but that will give you an idea of what, kind of root system it has. And I thought it was worth mentioning.
Monocots like grass, right?
Yeah, basically. Yeah, more or less. Yeah, C4 plants,
blade,
corn,
grass.
Yeah, grass.
Yeah,
which for the record, corn is grass.
Yeah. Oh, and it's funny because I hadn't really thought about that term so much until we started talking about the DLI LEDs and how they grow. They were growing monocots and stuff like that.
Right.
And
you're like, yeah. Can you pull up that the graphic that we have there? I believe it's going to give you a little bit of So there's the difference that you see between monocots and dicots. Pretty standard stuff. Vertical versus fibrous veins, things like that. It also depends vascular wise where the xylem and the phloem is, and also it talks a little bit about the floral part. So wanted to make that distinction, and just because we're always trying to spread the knowledge as much as we can, and there was something I kind of came across. I was like, you know what? I think this is a good thing to define at this time as well. So at the end of the day, a healthy root zone means a healthy plant, of course. Duh, right? Pretty obvious there. The root zone of healthy established shrubs will be approximately 1 to 2 feet deep and extend out past the drip line. Drip line being the edge of the plant, right, where actually water drips off and hits the ground. For a tree, I actually thought it'd be a lot more. I thought it'd be a lot more.
It's funny because I was being from the East Coast, and I grew up doing plants and shrubs. I started doing trees and shrubs when I was like 14 with my stepdad. They had little group of English gardeners that had different little things. But he would always take us to see some big trees that fell because one of his partners did trees. And it would always surprise me that root plate, I think they called it.
Yeah.
How you would have this giant tree that fell over and it would be wide. It would be really wide, but it wouldn't be that deep.
Right.
One of the things that we'll get into as we talk about the functions of the roots is literally it's an anchor.
Yeah, structure.
But literally, if it can't, and the thing people need to understand too is, maybe on the East Coast there's some bedrock, there's all kinds of stuff. So the tree is going to probably go a little more laterally.
Right.
Than it will as deep.
It's in West Virginia.
But you would see giant trees that fell over. The root plate would be sticking up. 15 feet.
Yep. We'd see it at Wolf Creek as well. We had a big ton of rain. It was like 4 inches of rain and then a huge wind event. It was like basically a microburst and it blew over these old spruce and pine and ponderosas like matchsticks. It was absolutely insane. So obviously, some plants do have, as you mentioned, shallower or deeper root zones. It really does depend on the, annual versus perennial as well is a piece of it. But most healthy plants.
And the weeds. Damn those weeds. They seem to have the deep ones.
You're right. And to answer I didn't even answer it. I thought trees would be, but it's 1.5 to 3 feet. So it is a little bit more than shrubs, but only by about a foot on the maximum, which is just kind of crazy to me. Most plants the roots do extend beyond the drip line, right? Because they're going to want to get all the way out to that edge and just a little bit more. So they're catching all everything that's dripping off the tree, of course. As plants root and grow, the roots spread out toward the drip line. And obviously they're searching for water. Major functions of roots being very simply absorption, conduction, storage, and anchorage, as you mentioned.
As we were talking.
So the root zone does consist of 4 different zones specifically. And why don't you take us away there, Gabe? And old number 1.
We're going to start off with the root caps, and they're sloughed off as the roots go deeper, creating a slimy surface,
right?
Which, as we will learn here in a little while, spoiler alert, rhizosphere,
right?
That provides the lubrication for it to kind of move through the soil. Then you have the meristem.
That's right. We said lubrication.
You're going to have that apical meristem behind the root cap produces new root cells that elongate. So I know with our crop, a lot of people do not run apical meristem. A lot of times we pinch them and we let them go. But the reality is, especially with our crop, the plant will mimic down below what it does up above. Obviously it won't go as deep.
What's also incredibly interesting is the way that the plant hormones affect different parts of the plant, right? So you have 4 main plant parts, right? You have floral parts, you have stems, you got leaves, and you got roots. Auxins, for example, will do different things to the to stem tissue than it does to root tissue. So like even people be like, oh, do you have to plant a seed the correct way? No, not at all. And it does have a bit to do with gravitational pull. But what's interesting is, so for a taproot, right, when it comes out, which by the way, you can't clip that taproot. That's one of the reasons I don't like germinating in paper towels, because it'll grow right into it. You pop off that little meristematic end to it. That's the growing region. Everything's done at that point. You could have just lost a unicorn. You'll never know.
Just pop in dirt.
In dirt. Here's the reality. The paper towel method, and I'm here to tell you, and everybody can try and argue that is nothing more than for germination testing. That's when a farmer pulls his bag out of a big old bag of seeds that have been stored, and he goes, shit, I wonder what the percentage of germination is. They put it in a paper towel. They look at it and they go, oh, we're still at 60, 70%. Cool. I'm good with that. They're not planting those. Okay. So putting them in a cup.
I've done all that tech.
Putting them in a glass and getting them, because all that's doing is imbibing the seed. So for that, like I'll even do that with peas, for example, before I plant them. Soak them overnight. They imbibe all big and fat.
I'll usually put them like in some type of glass for the night. I'll soak them overnight.
And I actually have no problem with that. But then honestly, I put it into the soil.
With most of the cannabis seeds that I do, they usually crack like pretty quickly.
Well, yeah.
Can I ask you on that? Do you guys, when you soak them, because I always soaked them, do you mandatory need them to be popped, or do you, if they're just like,
if you're going to soak them, you better crack them.
Yeah. So they should be cracked before you put them into the soil.
I've talked with Nick, with Phenotype Farmer in the past about vernalizing seeds, in which that's with like older seed stock. It's maybe 10, 15, 20 years old, in which he'll soak it, and then he'll freeze it overnight. And freezing it overnight will actually help the water penetrate that outer shell, get down to that embryo.
But you can also just use a little bit of a sandpaper and scratch the outside because it's a hard seed coat. I mean, really all you're doing in any of these techniques is just opening up that hard seed coat. So when you have older ones, sometimes they are a little bit harder to crack.
I mean, I saw Brandon Russ like cracking them.
If you think about this, there's little seed crackers and people use it for older ones and it's kind of interesting. But even think about this, a vegetable seed that's planted directly in, is anybody worrying about that? No, they put it in the soil and let it roll.
I don't disagree.
And it imbibes, and it's going to imbibe and pull in that water. And as long as you keep it properly moist, ta-da. Here's the thing.
Usually where
that shit's way smarter than we are.
And that's usually where people screw up is they overwater it. And then underwater and they get that dampening off.
Yeah. So, all about the meristem, right? But it is really important. But as I was mentioning too, the auxins, right, in root tissue, what it does is gravity pulls it to the bottom of the root and it actually slows down that cellular division at that point. What does that do? It creates the root turning down. It does the opposite above ground. So with stem tissue, what'll happen, it still falls at the bottom of the stem, right? But what it does is that actually makes it speed up cell division to make it elongate and go to the top. Very interesting stuff, folks. So even the same hormone can do different things. And in fact, heck, even a pure auxin 2,4-D is a weed killer. So it's really more about ratios, about situations, about where it's happening, things like that. There's not a wide brush that you can paint with these natural PGRs, which everybody thinks that's a bad name, but a plant growth regulator is totally natural. It's when you get into these lab derived varieties that we have the issues, right?
So the last two zones are the elongation zone. Is exactly how it sounds. You know, see your roots growing, and then the root hairs that form that absorb water and mineral nutrients from the soil. The root hairs are incredibly important.
Yeah.
A lot of times as we've discussed, what you see people do is they run it hot, they let it get a little dry, it burns those root hairs, and then uptake just becomes completely different. So, cultivating those roots, and, I was discussing it with a friend last night because I was talking about how we were writing this episode, and your vegetative time and that first 2-3 weeks of flower, that is the most important time to be developing these roots and really getting all this going, because after that, you're running on the framework that you built.
What you've built is is pretty much what you've got. And that's why when a plant that's almost good enough is never good enough. I remember reading that in a book somewhere, and it was really talking about when you're transplanting, going through and grabbing, and this is in a field situation, but grabbing the healthiest plants, right?
Yeah. That's why I cut lots of clones, so I can just call
it's exactly
every round.
Almost good enough is never good enough.
Yeah, you want to be, for me, I'm always cutting at least 25% more than what I need. I'll call the first round. I'll take 10%. And then after, when I'm going into flower, I'll usually take another 10% off and go in with my absolute. Yeah. And not for nothing, sometimes, and I like to do this just as fun, I'll put in one of the real crappy ones just because you really do. I've had some ones that have really surprised me, and I've been growing cannabis a long time, but I've had some ones that have really surprised me and it's funny because, but
that's also, let's be clear, that's on a hobby level.
Even when I was doing it for commercial, just to teach my guys something, I'd be like, hey, let's throw this bad one in there. Just let's make it. Let's see if we can get her to shine.
And watch it be a run and be like, oh,
no, I've had some ones that have come out real good, bro.
Some so that implies less than 50%.
You want to be selecting the best.
So let's get into really, what is the Rhizzzz fruit? We've kind of been implying about it, kind of implying that it is this ecosystem, whatnot, everything else, right? What it is specifically by definition is a subsurface living matrix. That's right, folks. Living matrix of soil particles, organic matter, plant roots, rhizomes, and perhaps most important, the diverse communities of microbes, the decomposed humic matter, process of resulting nutrients, and perpetuate the chemical, biological, symbiotic balance necessary for natural systems as a whole to prosper.
So that's
where all the magic is at. Don't kill it.
Don't kill it. I would like one person in the comments anywhere to chime in and tell me how hypochlorous acid doesn't kill that. Please, I will wait.
And now I will say, do I think it wipes it out completely? No, which is why I do think there's still a bit of a rhizosphere. But are we maximizing it? I would say no. And I do believe that life happens. Bacteria was here before us. It'll be here after us. You can't really eradicate it. But at the same time, we want to culture this. We want to culture this living matrix, right? I think, and again, this is. And I talk about this a little bit later, but guys, we're just scratching. I mean, with it like a little fingernail scratch, the surface of this stuff. It's very complex. There's
so much sugar. We don't know. There's so much sugar digestion. There's all these different processes that are happening that are so critical to the plant utilizing everything the most efficiently.
Well, let me see if I can get this name right next here. It's a little bit difficult, right? So a little bit of history on it, because where does Rhizzosphere actually come from? It's first used in 1904 by the German plant physiologist Lawrence Hiltner. Okay. All right. Hiltner.
No relation.
He used this to describe how plant roots interface with the surrounding soil. Very interesting that he was starting to see that and understand that there's like something more going on. Not even as a bigger scale, not even as a root zone scale, but he was seeing it at that small scale, right?
Beyond the 17 essential elements.
Beyond. So obviously prefix rhiza comes from the Greek meaning of root. Hiltner postulated the rhizosphere was a region, and this is a guess. He had nothing to actually prove this at this point, but he figured that it was basically a region surrounding the plant roots and populated with microorganisms under some degree of control by chemicals released from the plant roots. So he was already picking up that there must be some communication.
Some exudates.
Exudates. There we go. That's the word, right? That's the exudates. And these things now,
it's a bank.
Right. But we think about it like these things now, it's like, oh, of course plants talk to each other and all these things. And I was even talking to some folks the other day who don't really have any plants aren't necessarily a thing, whatever. And it was almost common knowledge that like, it's like, oh yeah, no, there's definitely a connection. So it's interesting to think in 1904, 120 years ago, that he's going, no, man, I think there's something going on here. And I think that they're working together. Mm-hmm. I just find that very, very, what a profound thought and what a forward thinking thought. So thank you, Mr.
If we go back on all the episodes that we've done,
right.
You're talking, and this is more towards the tail end of things, but, that 50, 60 years previous, there's a lot going on as far as people figuring out farming and elements and all. I mean, how many, all the element episodes that we went through, 1800s is really when people were starting to figure it out.
And they were starting to be able to prove it. Even if they didn't know completely what was going on, they were going, hey man, if I give it this, it does better. Mm-hmm. If I keep it from it, it does worse. So they're able to isolate those variables.
They couldn't keep moving west because the land started costing money.
It's going, what the hell do we do here?
So,
and really like what I like to talk about on all this stuff is like, why the hell does this even matter? Why is this worthy of study?
Because we like things that taste good and we think it's important.
Well, sure, but yes, that's actually true. Yeah. Okay. Reason being is the rhizosphere is a dynamic region, right? It's governed by the complex interactions between plants and organisms that are in close associations with the root. So there's so many things going on there that we really don't have any idea. The level of communication is really going on. What is going on to create those higher quality fruits? What signals are happening to defend themselves from insects or pest and disease attack, things like that? I mean, we really don't know. The composition and the pattern of these root exudates affect all microbial activity and population numbers, which in turn had an impact on the nematodes, microarthropods that share this environment. Beneficial or harmful relationships exist between rhizosphere organisms and plants and ultimately affect root function and plant growth. I thought it was great that was pointed out that you can have good and bad relationships there, right? It's not all inherently good.
It's funny.
Anaerobic versus aerobic bacteria, for example.
I went to a garden in Michigan that will remain unnamed. For a consultation. And one of the first things I did when I went in there was I knocked off the pots and I just smelled the roots.
Anaerobic versus aerobic bacteria.
And the head grower's looking at me. He's like, what are you doing? And I
checking your bacteria.
And I looked at him and I said, well, obviously something you're not doing, and it's like, the
smell of death is not good.
Yeah. And just looking at, now
necrosis, not good.
Most of us nowadays, we're using the bag, so we're not knocking the pots off. But realistically, like, I want to be able to, if you see beautiful, bright white roots with root hairs that are just, packed in there, that's what I want to see. If I see roots that are not bright white, I start asking questions. And yes, there is a smell that goes along with that.
Quiz question. Grambo, what are you actually smelling when you smell the soil?
You're smelling different ferments, I would imagine. That's kind of
bacteria.
what I'm thinking of. Yes.
You're smelling bacteria is actually what you're smelling. So you're smelling anaerobic or aerobic. Aerobic being air-based. That's the clean smell. Yep. That's that smell when you get that beautiful
soil.
Soil smell is a bacteria smell.
I'm from Iowa, so we had that black soil, and when you smell it, it's like, ooh, it just smells like healthy.
That's the smell of healthy aerobic bacteria.
Versus like if you guys have ever used Recharge and left it in I left it in a sealed container for a couple days.
That's the smell of anaerobic bacteria.
We've got hello.
Yeah, well, that's necrosis, death, black, and anaerobic bacteria is what we want to avoid at all costs. And that's why even when you open a bottle of anybody's products, we have products that are alive in the New Millennium line. Shake the shit out of it. Give it a good smell. Specifically, something like the Lightning Start, for example. It should have like a fermenty, blue cheesy bacteria type smell, healthy. It should not smell like death. If it smells like death, give us a call. We'll replace it. But I do want people to realize and keep in mind that the rhizosphere may also include, like we were saying, organisms that do not directly benefit or harm the plants, but clearly influence plant growth and productivity. What a fine line. What an it's like, wait a minute. So it doesn't directly affect the plant, but by it affecting the other processes that are going on, it helps the plant.
Yeah. So
wait a minute. Holy shit. Is it a cycle?
Yeah. So for instance, a bacillus will use something in the soil.
Right.
It will process, and then it'll make it available for the roots to be able to do
I don't know. I find, sorry guys, if I get excited nerd out a little, because I'm like, I think these things are so incredibly important, and really a better understanding of the soil root and soil seed interface is needed to manage these microorganisms, right? And if we do that, we can increase plant growth, we can reduce the impact of plant production, agriculture, and the environment. The benefits of studying the rhizosphere include the use of plant growth promoting organisms and the suppression of plant diseases and weeds using biocontrol agents. So, I mean, there is just a million different things.
We're going to have an episode about that here pretty soon as well.
Yep, absolutely. So again, I would say, again, why is it worth it? Why does it matter? Because with the greater understanding of the ecology and biota in the rhizosphere, the zone of increased nutrients, biotic activity interactions can be manipulated. You heard it right. Be manipulated in our favor to improve plant productivity and environmental quality. And so I think the big part is, and a lot of even what we talk about, what Neil's about, is how do we get the most out of the least, right?
Well, for him, and
he's not just throwing a bunch of stuff out. We keep it very available. We put those biostimulants in.
Well, people need to understand, when it comes to these principles, this isn't just for cannabis.
Right.
This is for fruits and vegetables and all the rest, and everything that comes along with it, because that's how you get the good fruits and vegetables, the ones that are especially delicious.
Yeah. Hey, would you pull up that graphic there as well? Let's take a look at this here. Yes. Where is it? There we go. So you can see some of the different things that are going. Obviously, that root system architecture. You've got the chemical gradients, nematode interactions, mycorrhizal interactions, bacterial associations, all of which have, obviously, I've got, a little more detailed description on, but don't want to get too tied up in the weeds, if you will.
Well, and as we get into the rhizosphere definition, we'll kind of, be able to point some of that out.
Yeah. And, go ahead and move that down a little bit, would you, Grambo? The one last thing I would say is an important reminder, the rhizosphere, as Gabe astutely pointed out when we were putting this together, is not all of the soil under our feet. Rather, it's a region of soil in the vicinity of plant roots in which the chemistry and microbiology is influenced. So close. I mean, well, and we're actually going to talk about that when we get into it. We're talking about actual distances here in just a little bit. No, we got it coming up. Okay.
That's interesting. Like nematodal interactions, all these different little branches and hairs, they're all doing different things. A plant is a community.
Well, it's funny. I was thinking we didn't highlight it in this episode, and I didn't really, when I was putting together the pest episode, I didn't think about it, but I was thinking about springtails. Okay. And how you'll get somebody will call you and they'll be like, oh, I got these little white worms crawling in my soil. And you're
bouncing around.
You're they're actually, that means things are good. That means things are good,
Move that up a little bit here, Grambo, because that does actually the other way, because it does talk about a little bit about the thickness right here. Yeah. So this I actually found to be very interesting as well. So this is going to talk exactly about where this region really is. And again, I thought rhizosphere, I was thinking inches. No. We're talking literally an average of 0.51. That's a half a millimeter average distance. Yeah. In all honesty, that's very, very little. It's literally just an area region of soil substrate that is directly influenced by root secretions and associated with soil microorganisms known as the root microbiome. So a half a milliliter. I mean, what's a human hair? Are we thinking together?
You want to see how
we're zoned
me
in.
and Jaron, man. I was on top of that, baby.
Okay, there you go. So you're talking
like the width of maybe two or three human hairs.
Yeah, 2 or 3 human hairs. Okay, wow. So, yeah, very small.
But the moral of the story is don't kill the slime.
Don't kill the slime.
Don't kill the slime.
Most root microbial associations in the rhizosphere and bacterial associations are rhizobacteria, right? And that is a pretty general term because I know you wanted to bring up a little bit about trichoderma and some other
fungus,
things.
You got bacteria, you have all these things that really, it all works together. It all works together and building those colonies.
Can I ask, what role does fungus play in indoor growing? That's interesting because like when I talk to like the living soil guys and stuff, it's like it's paramount. And you guys bringing it up just jogged my memory. It's like I don't think we ever discuss funguses.
But I think people. I think people kind of end up using that as a general term because when they think fungus, they think mushrooms.
I agree with that.
And so they're like, oh, well, you obviously don't want mushrooms.
It's more of a mycelium sort of situation, maybe?
Well, it's like the trichoderma is like a type of, I mean, I think there's over 5,000 different types of mushrooms. There's thousands and thousands of different types of fungus. There's thousands of different types of bacteria.
It's a huge, I mean, bacteria. Again, they're almost more.
They all serve a very specific purpose. You know what I mean? And it's actually funny because, you and I were talking about it and I had been listening to Brandon Russ the other day, in which dude's chock full of information. He's pulling it off of straight white papers. So he's not wrong about it, but he said one of the reasons people use the trichoderma over the glomus nowadays is because the trichoderma just is better and you don't want it to compete.
Right.
You know what I mean?
Right. And I found that really interesting. Right. And so if you're over flooding one thing, now you're out competing. Like this is it's balance. I mean, balance.
There was, depending on who was making what, there's a lot of different companies who focus on one specific, the Glomus enteratises, the Bacillus subtilis, whatever it is. They just focus on that, in which, it's still sometimes, you don't want to, I think cannabis growers in general have a wanting to, this one goes to 11.
Right.
I use Mycos, I use Azos, I use Great White.
What they want to do is, in my opinion, and I think this is just a natural human thing, they want to simplify it massively and go, oh, it comes down to this one thing. And that just isn't how the plant world works. No. Really, it's not how science works. These things are all systems based, right?
Well, and basically a lot of this stuff, it helps with the efficiency. It helps the plant do less work because the microbes and the fungus are doing the work for it, in which that's the way nature's set up.
That's how it's set up. And even as an example, rhizobacteria, which obviously what's a rhizobacteria? Well, it's bacteria that are associated with the roots. But the reality is they can be good, bad, or indifferent, right? And there's a nice deal where we can see the rhizosphere zone. It actually talks a little bit and shows you a little bit more specifically about where those zones are, what's going on. There is the mention of the symbiotic fungi mycorrhizals. One of the things about the mycorrhizals is they actually help plants uptake more nutrients by creating a denser network of roots. Essentially, they create more surface area. Dude,
that's where that Rhizzium, like I say to people, man, like you could put roots on a popsicle stick with that stuff. Like it is wild.
Are you stealing my thunder? We're coming up to that.
I wasn't trying to, but it really is one of those things where you're like, man.
Me and Gabe took a selfie with some Rhizzium today. That's how much we love it.
I mean, we could put that on Grambo's head.
I'll throw it on Instagram today. Me and Gabe took a selfie. Check us out on Instagram at Jug Dealers.
Jug Dealers. So you've got these things, these bacteria and the mycorrhizal fungi that are specific to those associations with roots, and they do a variety of different things. But again, super, super complex. And again, could you move that up there a little bit, Grambo? So this is such complex stuff. Again, we're barely scratching the surface. A lot of this stuff because we wanted to make sure that we weren't, mixing up and dicing words. We definitely like to have, use official definitions. A lot of this shit comes off the top of our head. Some of it is, as you well know, we're trying to pull this out from solid sources. But there's things like the bacteria plant interactions in the rhizosphere, the archaeal plant interactions in the rhizosphere, the fungal plant interactions in the rhizosphere, effects induced by other living organisms or microorganisms and plant microbes interactions in the rhizosphere. And last but not least, viral plant interactions. All these things are even different subsets of areas of study, within the rhizosphere. So, this is complex, deep stuff. And reality is, I don't know that we'll ever, as a species, ever quit studying this stuff because I don't think we'll ever figure it all out. I just don't.
They're aliens.
And then the conclusion is,
what if a time came where AI started talking with plants in a way we had no way of even understanding, and they became better friends than us?
Here's the deal, man.
I'm trying to sleep at night.
Here's the deal, man. Plants, Jayhawk and I discuss it all the time. Plants have been here way longer than us, man. Way longer.
Yeah, they've been here. They've been here before us. They'll be here after us. It's a joke that we always make. We, who's controlling who? Shout out to Michael Pollan and the Botany Desire. I've always loved that, and it just kind of
shout out to plants.
Yeah, shout out to plants. I love you, plants.
We love you, plants.
By the way,
don't betray us for AI.
Way, we did have a very rare event happen here in Colorado.
What, the corpse? Are you going to talk about the corpse flower?
Why not? Let's talk about the corpse flower.
I knew you were going to say something.
So we did at Colorado State University, and I can say we because I am an alumni of Colorado State University. So we just had a corpse flower bloom.
Was that a cutting off the one from the botanical
No,
garden?
It wasn't, but that's a great question. It was not. They actually said they got it as a gift for some rare plant symposium or conference that was done years ago. They've had it for quite a while. They said they basically hide it in the back most of the time because it looks like such shit that they don't want people to be, it looks
smells like shit too.
Only when it blooms. So, and actually my friend who works at the seed bank up there, she got to go in and cut out the side of it to collect pollen for preservation.
God,
so she got to
I don't know that I want that job.
Shout out Ashley. Ashley and my friend Will may be listening. He tends to listen here and again. But man, I thought that was so cool. Also had a blast with you guys.
It's a good looking flower, man.
It is when it happens, and that's
every couple 5 years.
No,
10 years,
I'm thinking
years?
7, 8 years, something like that.
I had a buddy. I had a buddy in high school whose dad snuck out a night cirrus from like Polynesia or some stuff. His dad was a scientist. He was a professor. And I remember they called me one year in the middle of the night at like midnight. They were like, bro, you got to come over the flower. It blooms in the middle of the night. Yeah. But it only has, same thing. It only
24
happens.
48 hours. You're saying that one, yeah.
Yeah, it only happens every 5, 10 something years. You're like, oh, we got to go.
Yeah. Well, and so I guess now I guess we can kind of consider this the second part of the episode.
Part D.
Part D. We're going to move in and talk a little bit more specifically about, again, we started wide and we're narrowing it down, right? Started at the root zone. Then we moved to the rhizosphere.